So today, as I said before, I'm going to show you a strategy called constant difference. Now, the clue in this strategy right here is the word difference. It says difference, and difference means the result or answer to a subtraction problem. So you're going to be using this strategy anytime when you're subtracting. If you recall, we used the give and take strategy when we are actually adding whole numbers or decimals. This is when we actually use the give and take strategy because we are putting two numbers together, so you can actually give and take from other things because of that commutative property of addition, meaning that we can add the numbers together any way we want as long as we're all adding everything together. So constant difference, we're going to start by doing a problem string, and we're going to start easy with 65 take away 38. Okay, so we're going to start with an open number line here, and I'm going to show you two different ways that we can solve this problem. So I'm going to show you first how to add to this number to get to 65. That's one way we can solve it. So I'm going to start with the number 38 here, and I'm going to try to find something that's easy for us to get to or add to get to 65. So first I'm going to jump, and I'm going to jump 2 so that it gets me to 40, which is a lot easier to figure out that I need 25 more. So then I can just add and jump 25 more to get to 65. And so the answer is 2 plus 25, which equals 27. So another way that we could have done this is by using an open number line, but we're going to do a subtraction. So we're going to actually take the 65 and start there. And then I'm going to hop to 60 by taking away 5 because that's an easy number. So I've taken away 5, and that means that I have so many left. So I'm going to hop, let's take away 30 more. So I'm at 35 now. So if I take away 30, it would get me to 30. And then I need to take away 3 more. So if I just take away 3 more, that would be 27. So both of these are strategies that I could solve this problem. All right, next I'd like you to solve these 3 problems. You can use either strategy you want. I just would like you to solve 61 minus 34, 54 minus 27, and 71 minus 44. Please pause the video at this time and figure out your work and then come back. Alright, so now you're back, and I have just done mine. I actually didn't hop, I just went, I knew that this was 27. I figured out that this one was 27 in my head, and I figured out that this one, I simply had to add 27. So the answer for all 3 of these problems is 27. And what's interesting about that, the difference is 27 for each of these problems, but they actually look like different problems. So now we're going to look at 2 more problems. We're going to look at 57 minus 30 and 70 minus 43. I want you to again pause the video and solve these 2 problems and come back. All right, so now coming back, I hope you notice that the answers for these, the difference for both of these problems are also 27. Now, what did you guys notice about these last 2 problems versus the first 3 problems? Take a moment and think about the differences between these 3 and these 2. If you notice that these 2 were easier than these 3, I would say the same thing. So when, obviously, these numbers are even or you don't have to like borrow, for example, so this has a 1 in the ones, and you have to take away 4, a 4 take away 7, a 1 take away 4. Now this one is different because it is a 0, but most people can actually figure out when it's the tens how to subtract. They know how to get to the right answer. So this one could be questionable, but this one was really easy because we had a 7 take away the 0. These 5 problems, some of these were easier to actually subtract or find the difference of the problem than others. So the goal of this constant difference is to actually find a strategy or make it easier for us to subtract. So we're going to try that with a few other problems. So we are going to be looking at a decimal this time. We're going to look at 17 2/10 minus 8 9/10. Now, if I were to draw this out on the number line like I did those other ones before, I'd start here at 8.9, and I'm going to try to get all the way over here to 17 2/10. Now, this problem looks complex. I'd have to do some hops, and I want it to be easier. So I'm going to look at this number here, or this one, and I'm going to decide this one can actually become 9 fairly easy. If I simply just add 1/10 to it, I can actually be at 9, which is way easier than figuring out 8.8 9/10. So I'm going to drop it to 9 here, but just so I don't change my problem, you can see the distance here. I have to add 1/10 over here to get to the real number on this side now, so it should be 17 3/10. So the difference between these two and these two numbers are the same, but this problem to me is easier. Now I'm going to write this like we did the give and take strategy. So I'm going to write my problem out here, 17 2/10 minus 8 9/10. And for this constant difference, instead of subtracting and adding, because we're not adding two numbers, we can't just give and take here, we actually have to, in order to change it and make this problem accurate, we have to add to both. So since I added down here 1/10 to this number, I have to add to this number so that my difference doesn't change. And once I do that, then this becomes 17 3/10, and this becomes 9. And then when we subtract, this is a lot easier to subtract. 3 take away 0 is 0, and 17 take away 9 I know is 8. So this is 9, 8 plus, or 8 3/10 more. So therefore I know that this one has to be 8 3/10 as well. All right, let's try one more problem with this. All right, now let's try just a couple more problems. So if I had, let's do 14 32/100 take away 3 95/100. Once again, we can draw a number line, but I'm going to rewrite my problem so that I may use the constant difference strategy. So at this time, I want you to pause it, but before you do, I want you to think of which one of these could we change to modify to make it a little bit easier for us to subtract. I hope you realize that this one right here is really close to being 4. So all I had to do is add 5/100 to it. And if I add 5/100 down here, I need to add 5/100 up here so that my problem adjusts accordingly. So this is 3.95, this would be 14 32/100, but if I add that 5/10 to both of them, then I'm going to be adjusting it. So it's still the same difference, but I just move or change the problem so it's easier. So once I add this, I'll get 14 37/100 minus 4. Now, 14, you guys can see, that's way easier. I don't actually have to do anything. I can do everything in my head. So it's 10 37/100, which looks way easier down here than what this looked like up here. Let's do one more. All right, the final problem we're going to do is 25 and 35 hundredths minus 2 and 80 hundredths. So I'm actually not going to use the number line at all because I've realized that I don't need to do it with the number line. But I am going to show you by rewriting my problem. So I could do the math right here, but there's this one right here that is a little tricky. So I am going to adjust this. I'm going to adjust this so that this becomes a whole. And how I'm going to do that is if I add 20 more hundredths, this will make this 3. So I'm going to add 20, whoops, I forgot my 0 up there, but that's okay. 20 hundredths to both of them. So this will become 25 and 55 hundredths. And this one on the bottom will become 3. Now if I subtract these again, this is a lot easier. 5 take away 3 is 2, and that's the only one that I actually have to do any real math for it. So the answer to this is 22 and 55 hundredths. The reason why the constant difference strategy is very helpful is because it simply takes these complex decimals and makes them into something that is a lot easier for our brains to calculate. All right, I hope that this strategy helps you. Good luck on using the give and take model for addition and the constant difference strategy for subtraction.